In this lesson, we will introduce the client-server architecture, and we will examine how applications and databases fit into this computing model. Now that you've had a taste of what it's like to interact with databases from within a Python environment, let's zoom out a bit to consider the bigger picture of how these technologies fit together. So far, the main tools we have worked with are a Postgres database, pgadmin, and some scripts that interact with the database, whether that be through migrations, raw SQL queries, or a Python ORM. However, up until this point, we haven't formally described this computing model. We will now introduce the client-server architecture, by far the most prevalent model for organizing these types of compute services. You may not realize it, but as a user of the World Wide Web, you're already familiar with this model. The basic premise for the model works like this. A user has a device which we call a client, and this client can request resources over the internet, such as a website, that will be served by a web server at the other end of the network in what we call a response. So a client sends a request and the server sends a response. And this communication happens over a network, namely the internet. Another example of client-server architecture is Postgres itself. In this case, the server accepts connections to the database from client applications and performs database actions on behalf of the clients. Every connection to the database server represents a client. This includes pgadmin. Whenever we execute an SQL query using pgadmin, we are sending a request to the database to process the query, and the database server will subsequently issue a response with the query result. In the same way, when we created database connections with the database adapters in our Python scripts, we were establishing a client-server relationship to allow for issuing query requests and responses. In the migrations exercise, the yo-yo migrations command line was acting as a client. You may be wondering what happens when there are more than 2 tiers in a system like this. It turns out a 3-tier architecture is very common. In this case, the clients may request some resources such as a video from a back-end server. Then, the back-end server must in turn request the video from a database server. The database server responds to the query for the video, and the back-end server processes and formats the query result before passing it on to the client. In this case, the second-tier backend is acting as both a server for the user and a client for the database. There are many benefits to this approach. Separating the concerns of presentation, business logic, and data storage into 3 tiers allows each to be implemented and deployed independently, and allows for scaling each tier as needed. So far, all of our examples have only dealt with one client at a time. But of course, the internet has billions of users, and most users have multiple devices. Consider how many phones and laptops are connecting to Twitter at the same time. With an app at that scale, they absolutely need multiple servers to handle all the incoming requests. And they would certainly separate their backend from their data resources, of which there will also be many. Coordinating all of these services and keeping multiple databases in sync is no easy feat. To help with this, there are lots of infrastructure and networking solutions, some of which will be introduced in the DevOps portion of the next course. For now, let's recap the core learnings. Clients issue requests over a network and servers issue responses. A typical client would be a user front end like a web browser or a mobile app. This is called the presentation tier. A second-tier service, like a web server, can function as both a server and a client in a 3-tier architecture. This is called the business logic tier. A database server, such as the Postgres server, allows clients to connect to the database and execute queries. This is called the data tier. In the coming lessons, we will look at creating a Python web server as part of a 3-tier architecture.